Guys, I am going to be teaching indicator 22 today, and I am going to break this up into two different videos, okay? One, I'm going to be showing you how to compare and order numbers, all right? And the other one is going to be absolute value, okay? So I'm going to break this into two different videos for you all, okay? So just a quick review from yesterday. Positive integers or positive numbers are numbers which are greater than 0. Negative numbers are less than 0. Then you have an integer which does not have a fractional part, so it consists of whole numbers and its opposite. And opposites are nothing but a number which is on the other side of 0 and the same distance from 0 on the number line. Like opposite of -6 would be +6 because 0 is the reflecting point. And so let's use these, and a rational number is a number in which the decimal is terminating. Very different from an irrational number, which is like pi, okay? So indicator 22, the learning target, I can compare absolute value and statements about order. I can describe absolute value of a rational number as its distance from 0 on the number line and connect it to a real world situation. And the last one, I can write, interpret, and explain statements of order for rational numbers on a number line and in real world context. So I'm going to start with the third I can statement right now in this indicator, the first part of the video, and then I will get to the first and second I can statements in the next video, okay? So right now we are going to talk about statements of order of rational numbers on a number line, okay? So I'm going to show you some cool shortcuts that you can use in this lesson. But in this lesson, basically, if you're comparing two numbers, okay, say I'm comparing 2 and -6, and you are asked which one is greater, okay? Now, always remember, a positive number is always greater than a negative number, okay? The way that is also determined is a number which is to the right on the number line compared to the other number is the greater number always, okay? So if I have a number line, okay, and if I have 0 here, to the right I have positive integers or positive numbers, okay? To the left I have negative numbers. Remember, 0 is like a reflecting point, like a mirror. So -2, -3, -4, -5, -6. Okay, now in the previous lesson I showed you how to graph. So you're supposed to go to where it's intersecting over here. So I have -6, which is over here, and then I have 2, which is over here. So obviously, if I'm looking at -6 and I'm looking at 2, I can see that 2 is to the right. This is to the right of -6. And so that is why it is greater than -6. But also, automatically you know that a positive number, a positive integer, is greater than a negative integer. So this is greater, and which side the mouth opens is the greater number. So remember that always, okay? Let's compare -5 and -3. Okay, so I'm going to show you a shortcut in a minute, but let's look at this. If you have a number line, okay, and let's say this is my 0, -1, because remember it's the opposite of, because this side would be 1, right? So this side would be -1, -2, -3, -4, -5, -6, and you can stop there. And let's say I am graphing, I have -5, which is here, -3, which is here. So -3 is to the right of -5. And so that is why, so -3 is greater, because the number is to the right of -3 is to the right of -5 on the number line. Okay, so make sure it's to the right of -5 on the number line, because like don't just say to the right, you've got to write where it is to the right. So therefore this is the greater number. Okay, now here is a really cool rule, or a shortcut for you to remember. Let's say I take positive numbers. Okay, so if I say 3 and I say 5, looking at both of these numbers, immediately you know that 5 is greater than 3 if you look at positive numbers. Okay, now look what happens when I make it into both negative. So this is negative, this is negative. So if that happens, take this, because over here 5 was greater. But I told you that from 0, it reflects backwards, okay? So therefore, what we're going to do, take this sign, and when we have both negatives, just flip the sign, okay? So when this happens, you can automatically see that this is the shortcut. If 5 is greater than 3 in the positive number side, if I have both negative, the sign just flips and -3 becomes greater than -5. So that is one thing just keep in your head, okay? So let's compare some decimals. And let's say I was comparing -3 and 800 and -3 and 8/10. Okay, so if you have this, first and foremost, just think of that shortcut that I just taught you, and if you think of both these numbers as positive first. So if I had positive, remember how we are comparing decimals, we have this and we take the same place value and we go like this. Okay, same place values and the same place values. If there's nothing here and x is 0, we start here, both are the same. So then we move to the next column and we can see that 8/10, this is greater in the positive number side. Okay, greater for positive. Okay, so if I just had positive numbers and I had 3 and 800 and I had 3 and 8/10, I can see this is the positive. The positive 3 and 8/10 is the greater number. Okay, so now what did I tell you? That if I have decimals or any form, when you flip it from positive to both negative, the sign completely flips. So do this, take this up, flip it. And that's about it. So then you know that -3 and 800 is greater than -3 and 8/10. Let me show you why. Let's say I had positive numbers, okay? And I am saying that we have 3 and 8/10 and we have 3 and 800. So I'm just going to start this over here, 3. And then since it's decimals, I'm going to start as, this is now positive, okay? I'm talking about the positive numbers. I just want to show you why it flips. So this is 3. So since it's a decimal, each section is going to have 10 parts, okay? So 4 will be somewhere here. So I'm just going to do 3 and 1/10, 3 and 2/10, 3 and 3/10, 3 and 4/10, 3 and 5/10, 3 and 6/10, 3 and 7/10, 3 and 8/10, 3 and 9/10, and then this is going to be 4 over here. Okay, so if I was graphing 3 and 800, it is definitely going to be between here. So 800 would be somewhere close to this part. Okay, so this would be around 800. And then I have 3 and 8/10, which is here. So in the positive world, you can see that 3 and 8/10 is greater than 3 8/800. Okay, now in the negative side, this exact number line flips backwards. Okay, so now this is negative because remember it is a mirror image but backwards. So this is going to be your -3. Okay, and then we have -3 1/10, -3 2/10. See how it's totally flipped backwards because it's a mirror. So -3 3/10, -3 4/10, -3 5/10, -3 6/10, -3 7/10, -3 8/10, -3 9/10, and then this would be -4. Okay, so now if I was looking at this, I have -3 800 over here. Okay, and I have -3 8/10 over here. So remember what we said? The number which is to the right of the other number on the number line is the greater number. Okay, so as you can see, -3 800 is to the right of -3 8/10. But I also wanted to show you in comparison to the positive line, the negative line, it is just flipped backwards. And so that is what happens. And that is why we take the sign, I'm saying 3 8/10. I've just flipped the sign when it's just two negative numbers so that you can see the comparison right there and how simple it is. Okay, so let's now compare fractions. All right, and the same rule applies here. Okay, same rule is going to apply here. So always take it as positives, and then what if I have both negatives? Obviously, if you have one positive and one negative, the positive will be the greater number. Okay, it'll be the right of 0 on the number line, negative will be to the left of 0 on the number line. So obviously the positive is going to be to the right of the negative on the number line. Okay, so now let's say I'm comparing fractions and I have -1/2 and I have -3/4. Okay, so always think about what if both were positive in fractions. Okay, so if they were both positive fractions, I would have had 1/2, I would have had 3/4, and just looking at the fractional part, I know that 3/4 is greater than 1/2. Okay, so I know that 3/4, if you think about it, think about quarters. You have 2 quarters, which is a half, and then I have 3 quarters, which is 3/4. Okay, so that's definitely going to be great. Because if I had done the same denominator, this would have been times 2 to get the same LCM, and this would have been 2/4, and then this is 3/4. Okay, so I just want to show that to you. So anyway, if we have the fractional part in the positive sense, we know that 3/4 is greater than 1/2. Now, what did I say? That if it's both negative, you just take this side, you flip it, and then we can see over here, -1/2 is greater than -3/4. So again, concept is pretty clear as to why. All right, we're going to let that bell thing. Okay, so let's say that this is positive. All right, and we're talking about half, we're talking about 3/4, so in the positive side. So let's say this is 0, this is 1 whole. So since the denominator is 4, we are going to break it up into 1, 2, 3, and the 4th is 1/1. So this is positive, okay? Right of 0. 1/4, 2/4 is 1/2. Okay, and then we have 3/4. So if I was plotting this on a positive number line, I'm looking at, okay, I have 1/2, which is here, 3/4, which is here, and so 3/4 is to the right of 1/2 on the number line. So if it's positive fractions, 3/4 is greater. Now look what happens on the negative side. Okay, so I'm going to take the same fraction line. And I am going to flip it backwards. I'm just going to do it this way here. Okay, so we have now, just think of this part here. This is 0, all right? And then this is going to be -1. We have 4 parts in the middle, okay? Now, this is the biggest mistake you all make. You start writing over here -1/4. No, guys. This is -3/4. Because remember, this is a mirror. The 1/4 flips backwards. So this becomes -1/4. This is -1/2. This is -3/4. So I just want to show you the same number line flipped backwards as a mirror. Okay? And so now when I look at it, I have -1/2 over here, and I have -3/4 over here. So obviously I can see that -1/2 is to the right of -3/4 on the number line, and therefore is the greater number. So please remember that on the fraction line, okay? Don't make careless mistakes over here. Our brain is so tuned to constantly just straight away putting this as 1/4 and 1/2 and 3/4 because we are used to positive numbers. But please remember, on the negative side, it is completely flipped like a mirror reflection, okay? So let's do a problem in which, let's say, okay, now if I say -4 and 5/6 and -4 and 1/6, okay, so I'm going to show you again the quick shortcut for this. So if I have -4 and 5/6, and I have -4 and 1/6, okay, so if I look at this, I can automatically see that if it was positive numbers, this would be 4 and 5/6, and this would be 4 and 1/6. Since this numerator is greater, this would be greater. Okay, now since they are both negative, look what happens. Again, take this up, flip it, and we have -4 and 1/6, which is greater. Because when you put this on a number line, okay, let's say this is -4, and then we have 6 parts. So this is -4 and 1/6, -4 and 2/6, -4 and 3/6, which is -4 and 1/2, -4 and 4/6, -4 and 5/6, and -4 and 6/6 becomes -5. So if I look at it this way, here is -4 and 5/6, and then here is -4 and 1/6. I just want to show that to you, which is to the right of -4 and 1/6 is to the right of -4 and 5/6 on the number line, and so therefore it is the greater fraction. Okay, we'll do a problem in which, let's say, let's use a real world problem, okay, real life application, and this is for temperatures for several cities in Arkansas. Okay, so we are using this for a real world problem now. And so in Arkansas, cities are, let's say Rogers is -6 degrees Celsius. We have Jonesboro, the temperature is going to be -7 and 8/10 degrees Celsius. Little Rock is 0 degrees Celsius. Hot Springs, the temperature is -2 and 5/10 degrees Celsius. And Texarkana the temperature is 3 degrees Celsius. Okay, please remember that this sign on the top, which looks like a little O, signifies the degree temperature. Okay, so now if I were to put this on a number line and figure out which city has the coldest low temperature, okay, and you were comparing. So if I go and I do 0 here, 1, 2, 3, to the left I'm going to be negative, -1, -2, -3, -4, -5, -6, -7, -8. Okay, so let's plot these so that you can see and compare. Okay, and so if I have Rogers at -6 degrees, so this is Rogers. Jonesboro is at -7 and 8/10. So that is going to be over here. This is Jonesboro. Little Rock is at 0 degrees, which is here. So this is Little Rock. Hot Springs is at -2 and 5/10, which is going to be over here. So that is your Hot Springs. Texarkana is at 3 degrees, which is here. So this is your Texarkana. All right. So remember, a number which is to the extreme left is going to be the smallest number. And that means that the temperature is going to be the coldest. Now, we know that 0 degrees is cold, okay? Think about winter time. And then when we are calculating, we're also looking at, okay, if it is going less than 0, it's even colder. So, it's beyond freezing, okay? So if I look at this and I look to the left, I can see that -7 and 8/10 is to the extreme left of all the other numbers. And so that is why this city, which is Jonesboro, has the coldest, lowest temperature. So this is the answer. Okay, so this is how we do the real world problems in this case. All right, I'm going to show you one last example, and it's asking which one is the least. Okay, so which one is the least is the question. Okay, that means the smallest. Least. All right, so we have the numbers -1 and 3/4. Okay, I have -1 and 9/16, and I have -1 and 5/8. Okay, so now you can see that all my denominators are different. So in order for you to compare, make sure that you find the least common denominator. Okay, and in order to do that, you do 4, 16, 8. You're trying to find the LCM of the denominators. Okay, so if I look at this, I know that all of them are divisible by 4. So I'm going to write this here. And I'm going to write 1, 4 times 4 is 16, 2 times 4 is 8. Okay, now when I look down over here, I can see that 1 is already in the simplest form, but 4 and 2 are still divisible by 2. So then I get 2 over here and I get 1 here. Now there's nothing common here, so I make an else for my LCM. 4 times 2 is 8. Times 1 is 8, times 2 is 16, times 1 is 16. So my least common multiple is 16, okay? So I'm going to put the same denominator for all of them so it becomes easy to calculate. This is 16 and this is 16, okay? Now, once I have this, make sure that you look at the number on the top. 4 times what gives me 16? 4 times 4. Whatever I do to the denominator, I do the same thing to the numerator, and I get 3 times 4, which is 12. 16 times 1 gave me 16, so 9 times 1 gives me 9. Okay, and then I have 8 times 2 gives me 16, so 5 times 2 is going to give me 10. All right, now if I look at this, now I have the same denominators. If these were all positive fractions, okay, if these were positive fractions, okay, I would know that, okay, my smallest where positive fractions are, it would have been 1 and 9/16, and then I would have had 1 and 10/16, and then I would have had 1 and 12/16. Okay, so this would have been my smallest. Okay, so this is what we would do. This is greater and this is greater. Okay, now remember what I said about negative. If they're all negative, okay, so this is negative 1 and 9/16, this is negative 1 and 10/16, and this is negative 1 and 12/16. Okay, so when they're all negative, because it flips on the other side of 0, we are going to flip these, and this is greater and this is greater. So guess what? Which one is the smallest? It is going to be your negative 1 and 12/16. So this is going to be my smallest because this is greater than this is greater than this is the smallest number. So my smallest number would be negative 1 and 3/4, and that would be my final answer. Okay, so this is how we compare and order numbers using the number line, or use the trick that I taught you as to how you flip, the greater than sign when you change to both to negative numbers. Also remember, if you only have a positive and a negative number, please remember the positive number will always be greater than the negative number. And always remember that if you have two negative numbers, the number to the right of the other number is always going to be the greater number. Okay, so this was part 1 of indicator 22. The next section we are going to cover is absolute value. See you in a little bit.